Hello students, this is the next chapter, thermal properties of matter. So we will discuss previous year advanced questions of thermal properties of matter in today's video. So this is the first question, 2011 advance. Here the question given as a steel wire of length L at 40 degrees centigrade is suspended from the ceiling and then a mass M is hung from its free end. The wire is cooled down from 40 to 30 degrees to regain its original length L. The quotient of thermal expansion of the steel is, means here required information mentioned, 10 power minus 5 per degree centigrade is quotient of linear expansion. And Young's modulus also given this much. And radius of the wire is 1 millimeter. And temperature cooled from 40 to 30 degrees centigrade. Initial length of the wire is L. Okay, this is the required data mentioned. Now how to analyze the question is, let us take this the rigid support. Initially a wire is hanging, this is the actual length. So actual length of the wire is L. Now when we connect a particle of mass M, same wire but we are connecting a particle having mass M. Due to weight of the particle, what happens? The particle length increases. Right here mass connected is M. Small m represents mass of the particle which was connected at one end of the wire. Other end is connected to the rigid support. Now due to this mass, length of the wire has elongated. Right? Wire has elongated due to weight. I have taken a wire, one end is connected to rigid support, other end particle is connected having mass M. Due to its weight, what happens? The weight wants to pull the wire in downward direction so that elongation takes place. Now this everything happened at what temperature? At a temperature of T equals to 40 degrees centigrade. Now to bring the wire to its actual length, so what we are doing? We are decreasing the temperature. Right? Initial temperature 40 degrees. Now we are decreasing the temperature to 30 degrees centigrade. So we know that whenever we decrease the temperature, basically materials will contract. Due to that, length will be decreased here. So this is the final scenario we can observe, so that the wire reaches to its actual length. Right? So length reached is again initial length. So if you compare here, this is the initial length where it has started and final length also same. Here initial length and final length is same. And now how to relate the Young's modulus and the change in length, original length, linear expansion. We know the relations here. So delta L divided by L can be written as alpha into delta T. This is equation number 1. All these equations I have given in the class in detail. Thermal properties of matter also we have discussed, as well as the mechanical properties of solids also I have given this equation. Right? So delta L by L equals to alpha into delta T. This is equation number 1. Now Young's modulus Y can be written as FL divided by A into delta E. Hope you remember this equation discussed in mechanical properties of solids. So from this equation we can write again delta L by L can be written as, so F divided by A into Y. F divided by AY. Let us take this is equation number 2. So if you compare equation 1 and equation 2, LHS are same. So change in length by original length. If LHS are same, we can equate RHS values. So therefore, F divided by AY equals to alpha delta T. Now F is what here? Nothing but the force. Who is applying force? The particle which is having mass M. So it is applying force on the wire. How much force it is applying? Nothing but its weight. That is, weight of the particle is mg. If you take this the particle, its weight mg is acting in the downward direction. So F value is mg, which can be written as A into Y into alpha delta T. So m value we need to find out, so that we rewrite this equation AY alpha delta T divided by G. Now whatever the data mentioned, just substitute the values here. A value, area of cross section of the wire can be written as pi r square. So it is pi into, in the question r value mentioned as 1 millimeter. You can see here 1 millimeter they have given. Convert this into meters. 1 millimeter is nothing but 10 to the power of minus 3 meters. So pi r square, that's by 10 power minus 3 whole square. And Young's modulus, y value given as 10 to the power of 11 into 10 power 11. And quotient of linear expansion, that is 10 power minus 5. And delta T value, from where to where we are cooling. So in the data again mentioned, delta L value is 40 degrees to 30 degrees. That means change in temperature is nothing but 10 degrees. So this is 10 whole divided by G value we know already, acceleration due to gravity nearly equals to 10 we can take. So here 10 value gets cancelled. So 10 power minus 3 whole square is 10 power minus 6. 10 power minus 6 into 10 power minus 5. That is 10 power minus 11 into 10 power 11. So both we can cancel here the terms. So that mass of the given object is nearly equals to pi. So that its value 3.14 basically we write. But here I am taking as 3 kilograms. Nearly equal value I have taken. Clear? So answer for this question is 3 kilograms. Mass of the particle is 3 kg. Next question. This is 2011 and this one is 2012. Before you just watch the video, as I am telling in the class also, just try to solve the question by yourself. Okay, pause the video. First you try yourself, then come to the solution. See this question. Assume that a drop of liquid evaporates by decrease in its surface energy. Okay. So that its temperature remains unchanged. What should be the minimum radius of the drop for this to be possible? The surface tension is T, density of liquid is rho, and L is latent heat of vaporization. So in here also, in fluids chapter we have discussed that surface energy. So general equation here, surface energy is changing, right? How much energy required for the evaporation purpose, that is available by nothing but the change in surface energy. So here we have to take the equation as dE equals to dQ. I repeat, why we have to take like this? Because how much energy it has released for decrease in surface energy, that energy is utilized as vaporization process. Here. So dE, how to write dE value? Surface energy equals to surface tension into small change in area, that I am taking as dA. Here dA. Because here this equation we know surface energy equals to surface tension into change in area, already we have discussed in fluids. That's the equation here we are using. So generally if you take any spherical object, what is the area formula? 4 pi into r square, right? So for a spherical object, area equation is 4 pi r square. But here small area we want change in area, that is dA equals to 4 pi into 2r dr, right? So from this we can write dA equals to 8 pi r dr. So substitute here. So we will get dE equals to surface tension into 8 pi r dr. So this is the one required equation we got. Now dQ value, how much energy is required for the vaporization purpose, that is supplied by nothing but this change in surface energy. To find out, let us take this is equation number 1. Now dQ value. dQ is what? dQ is nothing but general equation Q equals to m into L we are writing. Here small amount of heat, Q dQ equals to dm into L I am writing. So dQ equals to mass. How to write mass in terms of density? Mass can be written as density into volume. So density is rho. Volume, small volume I am taking dV. Because volume continuously changing here. As radius is changing means obviously spherical object volume also continuously changing. So rho into dV into L. Again, if I take the relation volume of the sphere, spherical object volume, how to write? So V equals to 4 by 3 pi r cube. So small volume we want dV, that is 4 by 3 pi is a constant, r cube can be written as a 3 r square into dr. Just substitute that value here. Whatever the things cancel, you can cancel. So 3 and 3 gets cancelled. So dV equals to 4 pi r square dr. Right, 3 cancel, 4 pi r square dr. Substitute here. So dq equals to rho into dv value is 4 pi r square to dr into length. Here L is the latent heat. Okay, this is equation number 2. Consider as equation number 2. Now if you observe, dE value should be equals to dq only. So just equate equation 1 and 2. So if we equate, you can rewrite this equation as rho into 4 pi r square L into dr, which should be equals to T into 8 pi r dr. Just to cancel the terms, whatever the terms we can cancel, left side and right side, make them cancel. So dr value gets cancelled, pi value gets cancelled. Here r square is there, here 1 r gets cancelled. 4 one time, 4 2 times. Right, what left here? Left side rho L equals to right side quantities are 2 left here and then T also left here. So left side R is also there, R. Now in the question they're asking us to find minimum radius of the drop. That means R value we need to get here. Minimum what should be the radius. So here we can write finally R equals to 2T divided by rho into L. So this should be the answer for the given question. Here. So R equals to 2T divided by rho L. So answer is D. This is 2012 question. Next one is, this is 2013. Right, questions seems to be very easy. If you remember, I think you may remember that I have explained this model in class also. Whenever they have given any metallic rod, given metallic rod you just treat as a resistor and compare with the current electricity analysis, so that the question becomes so simple. Two rods are connected end to end means you imagine that two resistors are connected end to end, series combination, right? So with help of that analysis I will solve this question. Process seems to be so simple. With less time you can solve actually. So it's the advantage of considering it as a resistor. Now see this question here. Two rectangular blocks. So they have given required data. Two blocks they have given. Configuration 1 were connected in series combination. In configuration 2 they have connected in parallel combination. Right. And thermal conductivity is given K and 2K for both the materials. So thermal conductivities K and 2K. Okay. Next one is, it takes 9 seconds to transport a certain amount of heat from the hot end to the cold end in the configuration 1. The time taken to transport same amount of heat. That means the heat flow in the first configuration should be same in heat flow in the second configuration. So then here what we need to get, time value they're asking. Means first of all in configuration 1 we and you just read the complete question carefully and understand the data. Two rectangular blocks they have given. One is connected in series combination, other is connected in parallel combination. Difference of temperatures are same in configuration 1 and 2. Thermal conductivities of the material mentioned already. How much heat is flowing in the first configuration? dQ. How much time it takes? 9 seconds. How much heat is flowing in the second configuration? As per the data, they said that same amount of heat, that is dQ. Then what they're asking, how much is the time taken in the configuration 2 for the same flow of heat, right? So here heat flow dQ divided by dt. First of all, general equation I am writing, dQ by dt equals to K into A into delta T all divided by length L. What is K, what is A, although I will not explain here because in detail we have discussed in the class already. You just open the notes and attend this lecture. Right. So dQ by dQ is dQ1 means the dQ amount of flow heat is flowing in the first configuration I am taking, and how much time it takes for the first. They mention here 9 seconds in the first configuration. So dt value is 9, which equals to, what is a K equivalent in series combination? if you observe, the first configuration is series combination. In series combination, K equivalent value is 2K1 K2 divided by K1 plus K2. How this formula came? Derivation is there in the notes already given, verified. 2 into K into 2K divided by 2K plus K, this is 3K. So K and K gets cancelled, this becomes 4K by 3. So K equivalent is 4K by 3. For the first configuration I have written, this is A value is A only, delta T whole divided by each length. If you observe in series combination, each length value is how much? Here to here length is L and here to here length is L. Treat the two given objects as a single object because we are writing total heat flow per second, right? So total length is nothing but 2L. This is equation number 1. Take it as equation number 1. Now come to configuration 2, second configuration. Formula is same here also, dq by dt equals to Ka delta T divided by L formula will apply here also. So dq heat is only flowing because here heat is the same as they said in the question. And how much time it takes, don't know. Consider this time as t because this value we need to get, small t value. Now K value, what is the K value in parallel combination? In parallel combination, K value is K suffix P. I am writing parallel combination, K value is nothing but K1 plus K2 by 2. So here 2K plus K, so that is 3K by, this is a parallel combination. So instead of K, we have to write here 3K by 2. And area, if you observe, this is having area A. In series combination, length will be increased. In parallel combination, area will be increased. Because here, one block over another block we are placing in parallel combination. So each thickness is A and other block thickness is A. So A plus A total thickness comes here as 2A. The total area is 2A. And difference of temperature is the same in both the configurations, whole divided by length is L. This is equation number 2. Just simplify equation 1 and 2. So here dq and dq gets cancelled. Here K, A, delta T, L. Here also K, A, delta T, L. Just divide equation 1 and 2, divide. So divide 1 and 2 so that you will get the final answer. If you simplify, this t goes to numerator, so this becomes t by 9. I use green only. So this is t by 9 equals to what left here? So 2 and then this is 2 by 3 and here 2 gets cancelled, right? If you simplify, 2 gets cancelled here, so only 3 left, and here anything gets cancelled. Here 2 one time, 2 times gets cancelled, right? 2 one time, 2 times. So in the numerator completely we left with 2 divided by 3 whole divided by, in the denominator quantities only 3 left. So this becomes 2 divided by 9. So finally t by 9 equals to 2 by 9. T by 9 equals to 2 by 9. 9 and gets cancelled. T equals to 2 seconds. Means dq heat flows in 9 seconds in the first configuration. Same amount of heat flows in 2 seconds only in the second configuration. Right? Answer is 2 seconds for this question. Here. Next one. 2014 advance this is. Parallel rays of light of intensity I equals to 912 watt per square meters are incident on a spherical black body, right? Intensity given here, intensity is this much and it is a black body kept in surroundings of temperature. This is the temperature of the surroundings given. Take Stefan's Boltzmann constant sigma, means sigma constant value given here, and assume that energy exchange with the surrounding is only through radiation. Means energy exchange can be different processes, right? I told you in the class, basically conduction we are dealing and radiation we are dealing maximum. In JEE syllabus, convection is not there. That may ask in theory exams only. Right. The final study state temperature of the black body is close to. Right. So here data we can write whatever the data they mention. That data better we write. dq by dt, first of all, whatever the equations we know, we just write here the terms. So I value given 912 watt per square meters, and T value, temperature of the surroundings, Ts value given, temperature of surroundings how much, 300 kelvins given, and sigma value, sigma is a constant, its value is 5.7 into 10 to the power of minus 8 watt per square meters and Kelvin power 4. Right, what is the final steady state temperature of the black bodies? It's a direct question only. So directly we can mention here the value dq by dt equals to E sigma A T b power 4 minus T s power 4. Right, this is the heat to flow per second equation. In Newton's law we have discussed this one in thermal properties. So direct equation we can apply. Right. So dq by dt equals to E sigma A T b power 4 minus Ts power 4. So in the question about the spherical black body, right? It is a spherical black body. So dq by dt is nothing but power we can write, right? Energy by time. Heat is nothing but energy. So energy by time is nothing but power. So power equals to E sigma A T b power 4 minus T s power 4. So P value. Power, how to represent power in terms of intensity? Since well, here small formulas are there, these are important to remember also. So power equals to intensity into area. P equals to I into A. So just substitute that value here. I into A equals to E sigma A T b power 4 minus T s power 4. Here very carefully you have to analyze, because A and A generally you cancel the terms left side and right side. Here we should not cancel the terms. This A stands for total area of the body. Entire area we have to take whenever you are writing heat exchange with the surroundings and the body, then you have to consider total area. When you are discussing about intensity and area relation, here we have to write only effective area. That means through what small area, so light is incidenting or light is flowing outside. Okay, so small a represents, here A and A we should not cancel. Right side A we have written in the equation, that is basically total area of the body. If you take a total sphere, a hollow sphere, so it is total area of the object. Now left side we have written power equals to I into A. Here this left side A, whatever I have written, that represents only small portion through which light can enter from inside to outside, or outside to inside also light can come. So it is only effective area, not the total area here. So if I take a sphere, hollow sphere, so intensity we can write I only. But for a hollow sphere, effective area is basically a circle only. Parallel light rays are falling, so that a circular portion will get affected. So area we have to write here pi r square. Here pi r square, which equals to E sigma total sphere area is nothing but 4 pi r square into T b power 4 minus temperature of surrounding given in the question 300. So 300 whole power 4. This point I will explain a bit detailed, because here you have to understand. Let us take, there is a sphere, spherical object. You do not think this as a circle. Okay, it is a solid sphere. Here 3D diagrams not available. right? It is nothing but a spherical object. I will write here. Spherical object. You imagine it is a plastic ball. Okay, plastic ball. That is, it is a 3D, three-dimensional object. So some light rays are falling parallel. So let us take, this is one light ray, this is one light ray. Here light rays are falling parallel direction. It means these light rays can enter through this circular portion. We can take inside. If I draw one circle, right, all these light rays are passing through the circle area only. So that's why whatever we have written this is a circular cross section. Circular cross sectional area. Understand? Because light rays are coming parallel. They are not passing through entire area of the sphere. Only affected area is there here. So what is that affected area? Nothing but this circular portion area. So that's why I have written here pi r square. And here exchange of heat can take place with the surrounding through the entire object. So here I have written 4 pi r square right side. Hope it is clear to you, because it's a very minute point. Generally student will cancel A and A, will choose the option which gives the wrong result, will be wrong. So we have to be very careful about the area analysis. So if you simplify all these equations by substituting the values, intensity given in the question itself, it is 912. 912 is given. Whatever the terms cancel, you can cancel also. Pi value cancel here. R square and R square cancel. So 912, intensity given 912 equals to, for a black body, what is emissivity value? Of course, one small e value is 1, and sigma is a constant. Its value given 5.7 into 10 to the power of, here in the question given. So sigma equals to 5.7 into 10 power minus 8. This is 10 power minus 8 into t b power 4 minus 300 power 4. So just simplify everything so that finally you will get TB value as 330 kelvins. This should be the answer for this question. This is a very direct question, but entire this question depends on nothing but the area. So student has to analyze very carefully which area we need to choose. Intensity means only effective area how to take, and exchange of radiation with the surroundings and the body means the total area of the object you can consider here. Right. Next one is also 2014. Here 2014 repeated questions meaning is nothing but paper 1 and paper 2. Advance basically morning paper 1 and afternoon paper 2. So here paper 1 question, paper 2 question, both I am explaining. Right. This is again 2014. 3 rods. Just read the given question, pause the video, try by yourself, then come to the solution. 3 rods of copper, brass and steel are welded together to form a Y-shaped structure. Area of cross section of each rod area of cross section is 4 centimeters square. That means area is the same. End of copper rod is maintained at 100 degrees centigrade. Means the copper rod one end temperature is 100 degrees centigrade, whereas ends of brass and steel are kept at 0 degrees centigrade. Okay, means there is a copper rod and brass and steel rods are also there. One end of copper rod temperature is 100 degrees centigrade, and one end of other two rods, brass and steel, temperatures are 0 degrees centigrade. All these three are connected as a Y shape. Okay, and all are having same area as per the question. And the length of copper, brass and steel rods are this much. Lengths are given here. Okay. The rods are thermally insulated from surroundings except at ends. Okay, means there is no exchange of heat with the surroundings, you can say, except the ends of the rods. Thermal conductivities of copper, brass and steel are this much. These are the values given. Rate of heat flow through copper rod is, what is the rate of heat flow through copper rod, they're asking. Okay. So let us draw the diagram here. But I type this one. So this is one rod. This is another rod. This is another. 3 rods are there. Okay. So one is copper and one is brass and other one is steel. Easy question only. Okay, little bit calculation, nothing. But data you have to write carefully. If you write brass instead of steel, copper, if you change, answer will be different. So with different colors, I'll write the data. Area of cross section is same. So area is A, area A, here also A. Now, one end temperature. Here the temperature of copper is 100 degrees centigrade. Here 0 degrees centigrade. Here 0 degrees centigrade. And junction temperature. Here this is the junction. Let us take junction temperature is T. In the class I discussed, this is a very important model, many times repeated in JEE mains. Okay, important model, Y-shaped rod. So junction temperature is T. Right, next length of the rod also given. Copper is 46 centimeters and brass rod is 13 centimeters and steel rod is 12 centimeters. Okay, length also given. And thermal conductivity of copper is 0.92 and for the brass thermal conductivity is 0.26 and thermal conductivity of steel is given as 0.12. What is the process here? So question asked is rate of heat flow through copper rod is how much? Okay, first of all find the junction temperature. If you know the junction temperature, then you can use the equation dq by dt equals to Ka delta T divided by L. It's a simple question on it is. So process step 1. Find junction temperature first. How to find the junction temperature? I told you whenever it's a case of finding junction temperature, you take in a single line. Don't go for any other method, you may get confusion. Take a single line. How to solve this one? So formula is Ka delta T by L. So here also just find out the junction temperature by adding all. So K value I am writing for the copper wire. Kc A delta T. Copper wire, heat flow in the copper wire plus heat flow in the brass plus heat flow in the steel wire should be equals to 0. If you make it equals to 0, you will get junction temperature. Once you get the junction temperature, then use dq by dt. Right, first of all, copper Ka delta T. Delta T value is 100 minus T divided by length of this copper wire is, length of this one is 46. Also, Kc thermal conductivity also given. Right, directly will substitute. Directly I am writing the easy question. Hope you can do it. So 0.92. Right, Ka delta T by L plus. Now brass wire. K value given 0.6. 0.6 into A into delta T value. Don't take here 100 minus. Here better you take directly junction temperature minus other temperature. Listen my words. First write junction temperature minus other temperature. Directly you will get the answer. So T minus 100. Better you take this. Otherwise what you have to do? If you take 100 minus T, then dq by dt in the copper wire should be equals to dq by dt in the brass wire plus dq by dt in the steel wire. This is the process you have to follow. I am not doing that addition process. I am just directly taking T minus some temperature. I am adding and making equals to 0. Both will give the same answer only. At 0.26 into A into delta T value is T minus 0 whole divided by length of brass wire. How much is mentioned? 13 centimeters. I just to shift this everything towards left. Plus other rod is also there, not only 2, 3 rods are there. Steel, thermal conductivity of steel is how much? 0.12 and A value is A only. Delta T value here also T minus 0 whole divided by length of steel is 12 which equals to 0. So which formula I have used till now? That is nothing but dq by dt equals to Ka delta T divided by L. This is the equation I have applied for all the 3 rods and I have added all 3 and made equals to 0. If you simplify this equation, whatever the things gets cancelled, here area gets cancelled because area is the same dimension. So that area can write right side also it becomes 0 automatically. So t minus 0, t minus 0, here also t minus 0. First one is t minus 100 because copper one end given as 100. So simplify this everything. So finally we will get t equals to 40 degree centigrade. Here, t value will get 40 degree centigrade. Now you substitute this value in rate of flow of heat for copper because in the question they are asking what is the rate of flow of heat in the copper wire. So rate of heat flow in copper. So equation is dq by dt equals to Ka delta T divided by L. So K value for copper, how much is the K value? 0.92. A value already mentioned. Here you need to convert everything into SI units because single rod we are analyzing. Area of each rod 4 centimeters square. Convert this into meters. So 4 into 10 to the power of minus 4. So 1 centimeter. So we are writing here. Convert into meter. 1 centimeter square they have given, so 10 power minus 2 whole square, so 10 power minus 4. Delta T value is how much? One end is 100, other end we got as 40 junction temperature, all divided by length of copper wire is 46 centimeter. 1 centimeter is 10 power minus 2 meters, so 146 into here also 10 power minus 2. So just to simplify, whatever the terms gets cancelled here, so final answer will get as 4.8 calorie per second. So dq by dt equals to 4.8 calorie per second. Don't get any confusion. I have converted everything into SI unit. Okay, whatever they mentioned, everything I have converted into SI units. But final options given in terms of CGS unit, again you need to convert. So everything in CGS unit. Okay, everything in CGS unit means you no need to convert also because K value we have taken. Remove this one also, no need to convert, no need to convert. Bas. Direct answer will get. Conversion is not required because options are given in terms of CGS one. So directly leave it like this. 0.92 into 4 into 100 minus 40 divided by 46. So 4.8 calorie per second. This should be the answer for this question. Here. That is why I told in the class, thermal properties, thermodynamics and KTG scoring. A little bit calculations only, rest everything is easy. Not very heavy chapters like rotation motion, fluids. Okay, it is not like that, it's simple chapters. You can score well. Right, this is 2015 advanced question. Two spherical stars A and B emit black body radiation. The radius of A is 400 times that of B and A emits 10 power 4 times the power emitted from B. Okay. The ratio lambda A by lambda B of their wavelengths and which the peaks occur in their respective radiation curves is. Okay. Means it is the question which relates Wien's displacement law also. Here we need to use Wien's displacement law as well as radiation equations also, both. So let us start the question here. First of all, required data write the star A, this is star B. Two stars they have given, star A and star B. Now the radius of A is 400 times that of B. Let us take radius of B, I am taking as RB. That means radius of A is 400 times of RB. Right. Next, A emits 10 power 4. This is the data. Just very carefully we have to write the data. A emits 10 power 4 times the power emitted from B. Let us take power emitted by B star is P suffix B I am taking. That means power emitted by A equals to 10 power 4 times of power emitted from B. Okay, this is the data. Now write the equation. So heat exchange equations we have to write. It's a black body radiation they said in the first line of the question only. That means you can use dq by dt equals to, it is only emission process. If you see the question, two spherical stars A and B emit black body radiation. This is not the exchange, not a net flow of heat. They're asking emission question, heat emission. That means dq by dt equals to E sigma A TB power 4. Temperature of body. TB stands for temperature of body, or T power 4. This is general equation we have written. Now dq by dt is nothing but energy by time is called a power only. So power of A, star A I am writing, power of A equals to, black body means small e value 1, sigma is a constant, and A value, what is A? A is nothing but area. So pi r A square. Right? So 4 pi r square, it's a spherical object, so 4 pi r A square into T power 4, temperature of A, star A I am writing, that's why temperature of A power 4. So what is power of A given in the question? 10 to the power of 4 times of power of B. So equals to 1 into sigma into 4 pi into radius of A. Radius of A is 400 times of radius of B whole square into T A power 4. Let us take, this is equation number 1. Similarly, write for star B. This everything is for A. For star A. Whatever the data I have written equation 1, that belongs to star A. Next, for star B, power of star B is PB equals to, again E value is 1 because both are black bodies here, emit black body radiation they said, means small e value becomes 1. E is 1 sigma 4 pi r b square into T B power 4. So this is equation number 2. Whatever the equation written here, so this is for star B. For star B. Right. Now divide both equation 1 and 2. So if you divide equation 1 and 2, you get the relation like PB and PB gets cancelled. So 10 power 4 equals to 1 cancel, sigma cancel, 4 pi cancel, RB square cancel. So what left here? 400 whole square T A power 4 divided by this side only 1 left, and this side everything gets cancelled, only T B power 4 left. Just rearrange the terms. T A divided by T B whole power 4 equals to 10 power 4 divided by, say, 400 into 400. So this is, as a square is there, directly you can write also. So 400 into 400. So 10 power 4 divided by 4 into 10 to the power of 4. So both gets cancelled. So these two gets cancelled. So TA divided by TB whole power 4 is 1 divided by 4. Now lambda, but they are not asking this one. We want lambda A divided by lambda B relation, right? So lambda A divided by lambda B is how much? So any further we can simplify here. TA by TB whole power 4 equals to 10 power 4 divided by, so this is also 4 into 10 power 4. Okay, right. 1 minute. So 400 into 400, अरे यार 16. चलो ठीक है. This is 16 into 10 to the power of 4, right? So this also 16. Okay. So that means TA divided by TB equals to 1 divided by TA by TB whole power 4 equals to 1 by 2 power 4 also I can write. So final answer becomes here 2 only. Here Hope step by step not required. Yeah, this is not LKG UKG. So TA by TB whole power 4 equals to 1 by 16. So TA by TB equals to 1 divided by 2 power 4 also I can write. So that means TA by TB value how much? 1 by 2. Khatam. Now if you know TA by TB value 1 by 2, so lambda A divided by lambda B is how much? This is nothing but TB divided by TA, because wavelength and temperature both are inversely proportional. So whenever welding, if you go to any market or somewhere else, you just observe next time. Whenever welding they are doing, so you can observe that one end of the rod they are heating. At the time of beginning of heating the rod, you can see reddish color. Right, rod becomes first of all red color. After certain time, half an hour or 45 minutes, gradually the color converts to yellow, then maybe orange, then blue color. Means what happens? Temperature is increasing with respect to time. Obviously, we are continuously supplying heat, means temperature is increasing. As temperature is increasing, color is changing from red, then orange, then yellow, then blue. Means temperature increases, wavelength decreases. So temperature and wavelength both are inversely proportional. So lambda A by lambda B equals to TB by TA. So wavelength ratio of A to B equals to TA by TB 1 by 2 means TB by TA becomes 2. So this is the final answer for this question. Yeah. Now next question is 2016. Just read the question once. A metal is heated in a furnace where a sensor is kept above the metal surface to read the power radiated P by the metal. The sensor has scale that it displays log base to P by P naught, where P naught is a constant. Okay, P naught is a constant. When the metal surface is at a temperature of 487 degrees, the sensor shows value 1. Which means there is an instrument called as a sensor. Whenever temperature is 487 degrees centigrade, what is the reading shown here? 1. Fine. Assume that the emissivity of the metallic surface remains constant. What is the value displayed by the sensor when the temperature of the metal surface is raised to 2767 degrees? Means as the temperature changes to 2767 degrees centigrade, what is the value of the sensor? Okay. So that means you need to get an idea here how to analyze the question. As per the question, they said P naught is a constant. It's a radiation process that we understood after seeing this. This is not a conduction question, right? It's very clear. Emissivity they said in the question, last line emissivity they said. Here also emissivity they mentioned. That means no doubt it should be a radiation process. Okay. A radiation process means what we can take here is general equation, that is dq, rate of flow of heat, dq by dt equals to E sigma A T b power 4 minus T s power 4. What is the TBTS? I think you already know. TB is temperature of the body, TS is temperature of the surrounding. Okay. So dq by dt is nothing but power. So basically you can write here power is directly proportional to fourth power of temperature. Power is directly proportional to fourth power of temperature. Now to remove this proportionality, I just introduce a constant here. P equals to P naught T power 4. Now just write this equation as P by P naught equals to T power 4. Take log base to both the sides. So log base to P by P naught equals to log base to T to the power of 4. So try to rearrange whatever they have given. P by P naught equals to 4 log base 2 into T. Log base 2 P by P naught equals to 4 into log base 2. T value is how much? Initial temperature. Go to the simple things only. Step by step, just write it. This is not physics actually. Mathematics side we are going. Physics is over. If surrounding temperature is less, body temperature is more, heat exchange takes place. How much heat? dq by dt equals to E sigma A Tb power 4 minus Ts power 4. Now we have to introduce here max and we need to get the required relation. Without max, there is no physics. So that's why your calculation should be very strong and particularly advanced. So that's why in the class also I don't give any shortcut methods. I don't believe in shortcuts. Shortcuts, if you know, it's fine, but shortcuts has a conditions. If x equals to y, then only this shortcut available. If 10 equals to 2x, then only shortcut available. So shortcut has a condition. So that's why depend on the actual method only. For solving advanced questions or any other tough questions, better you know the original process here. So here initial temperature, how much is given? 487 degrees. So 487 degrees to convert into Kelvin. So this is 7 3 10, so 16. So this is 4 to 6 760, right? So this is 760. So therefore what we can write is 4 log base 2 760. Its value is how much? 1. Because in the question they mentioned sensor reads how much reading. How much is the reading given by the sensor at 487 degrees centigrade? 1. See here they mentioned. So that's why whatever the value we got here have equated to 1. Okay. Next, what is the reading at 2767 degrees centigrade? We need to find out. Okay. For that again, process will be continued. So let us start from here. Right. So again the process is this time also I just apply the rule P equals to P naught. This P dash I will take. P equals to P naught T power 4 is the actual relation. So I take here P dash. P dash equals to P naught T power 4. So P dash by P naught equals to T power 4. Just to take here also log base 2. P dash by P naught equals to 4 log base 2 T. But what is the temperature this time? Second case, at what temperature? So that is 2767. This is degrees. We need to convert into Kelvin everything. Absolute temperature scale we have to take. 273. 7310. This is 7714. 7310. So 213. 3040. Okay. So log base 2 P dash by P naught equals to 4 log 2. P value is 3040. So this is the reading, but this reading we need to convert into known terms. So what is known terms? Here 760 is there. Now better you get this is 760 form. So the question becomes easy. So rewrite this everything as 4 log base 2 3040 760. How many times? I think 4 times. 760 into 4, right? So 4 log base 2. We'll do one thing, log AB. So how to write log AB equation? Log AB is log A plus log B, right? 4. This is in the form of log AB. So log A plus log B. Right. So now I just multiply with 4 inside. So this becomes 4 log base 2 760 plus 4 log base 2 4. Okay. But already we know what is its value. This total value is how much? 4 log base to 760 means nothing but 1. So substitute here. So this is 1 plus. Here 4 is there. So 4 log base 2. 4 I am writing as 2 square. So this becomes 1 plus this 2 you can write here only. So 4 into 2 becomes 8. So 8 log base 2 and this is 2. So log base 2 into 2 means nothing but 1. So 1 plus 8 which equals to 9. So this should be the answer for the given question. Here nothing is there, simple things only. You just practice 1 and twice, you will get the. And here nothing but log base to 760 into 4 equals to 1. They have given in the question itself. You just try to bring that relation with help of the second temperature also and then compare. So that you will get the answer. Simple question also, not tough for category. Right, 2017 advanced this is. Let's read the question and understand this one. A human body has a surface area approximately 1 square meters. Okay, area of the body given. The normal body temperature is 10 Kelvin above the surrounding room temperature T naught. Okay, surrounding temperature is T naught and its value mentioned already this much. For T naught equals to 300 Kelvin, the value of sigma T naught power 4 is this much. Right, because we know the formula dq by dt equals to sigma A T power TB power 4 minus TS power 4. So for that they have given here sigma T naught power 4 value is 460. Okay, where sigma is a Stefan's Boltzmann constant. Which of the following option either are correct? Okay, first I just write the general equation as per the data will convert. Later will verify the options. So first thing we can write here dq by dt. dq by dt equals to E sigma A T b power 4 minus T s power 4. Now here change is very small. You can observe here. What is the surrounding temperature? They have given 300 Kelvin. Right? This is the surrounding room temperature. And what is the temperature of the body? 10 Kelvin above the room temperature. Means the difference is very less. Only 10 Kelvins. So I just rearrange this entire data like dq by dt is nothing but power only. Directly I am writing here. Power equals to E sigma A. This is temperature of the body. TB stands for temperature of the body. I'm writing this one as T naught plus delta T. T naught stands for surrounding temperature. So T naught plus delta T whole power 4 minus TS means nothing but T power 4. If you have any confusion, I just mention this side. T naught is surrounding temperature. Here. Now, so P equals to E sigma A. So T naught is there here also T naught. I'll do one thing. T naught power 4 I just write it outside. So that this remaining equation becomes 1 plus delta T divided by T naught whole power 4 minus T naught power. So T naught we have written already, here 1 comes. But T naught power 4 I have taken as common. So this is the remaining equation. What is the purpose of writing T naught power 4 outside? Because if you write this sigma T naught power 4 outside, its value already mentioned in the question. Sigma T naught power 4 is how much? 460. Here. Now, so P equals to, keep like that only for a certain time. E A sigma T naught power 4. Right. Now here I will use binomial approximation. Because if you compare delta T value is how much? Only 10 kelvins. What is the T naught value? 300 kelvins. So very large. So delta T by T naught value is very less than 1. So that we can write here not very of course. It's a very less value. So directly binomial approximation I am applying. This can be written as 4 plus 1 plus 4 delta T divided by T naught minus 1. Here this plus 1 and minus 1 gets cancelled. So remaining is P equals to E A sigma T naught power 4 to, this is 4 delta T divided by T naught. Now whatever the terms gets cancelled here, make them cancel. T naught and T power 4 cancel. So P equals to E A sigma T naught cube into 4 delta T. Now whatever the options given, just to compare the option, because this is the general data I got with help of given question. This is the equation I got. Now I will verify the options. So first option is the amount of energy radiated by the body in 1 second is close to 60 joules. Okay, that we will verify now whether it is 60 joules or not. We'll verify. Other, if the surrounding temperature reduces by a small amount delta T naught, which is less than T naught, then to maintain the same body temperature, the same human being needs to radiate 4 sigma 4 sigma T naught cube delta T naught. Here we got 4 sigma T naught cube delta T. Yes, so option B is right. So then what about A? Here A is also there. In the question what they mentioned in the beginning we read here. A value how much? 1 square meters. Since A equals to 1 square meter, so whatever the option B given, that is correct. And option C, just to read it. Reducing the exposed surface area of the body, example by curling up, allows humans to maintain the same body temperature while reducing the energy lost by radiation. Yes, here if you observe, power is directly proportional to surface area only. If area is reduced, that means what happens? Object emits very less radiation, so that almost it can maintain the same temperature. So option C is also yes, correct. Next one, if the body temperature rises significantly, then the peak in the spectrum of electromagnetic radiation emitted by the body would shift longer wavelength. No, wavelength is inversely proportional to temperature. Just now we have seen Wien's displacement like this. Temperature rises means what happens to wavelength? Wavelength has to decrease. But they said that it is shifting towards a longer side, increasing side, which is wrong. D is wrong. Now what we need to verify? Option 1. The amount of energy radiated by the body in 1 second is close to 60 joules, they said. So just verify it. How to verify? You can take the equation, any equation you can take here and just verify. We'll do one thing, we'll take this equation only for the verification process also. P equals to E A sigma T naught Q 4 delta T. So take the required values here, whatever the required values, just to check it. Sorry, 1 minute. T power 4. I'll take this equation. T power 4. 4 into delta T divided by T naught. Just verify, put the values here. E value becomes how much? Approximately I am taking E value as 1. Here E value I am taking approximately as 1. So if you take E value as 1, A value also, this value is how much? 1. This value is how much? 1. What is this? Sigma T naught power 4. In the question they mentioned sigma T naught power 4 is how much? 460. And this is a 4 constant. What is the delta T by T naught? Delta T value difference given in the question 10, T naught value 300. Now you do one thing. So P equals to 1 into 460 into 40 divided by 300. So here anything gets cancelled. Here these two zeros cancel, these two zeros cancel. So P equals to what left in the numerator? 46 into 4 divided by 3. I just use the calculator. Just let me check this one. So this is 46 into 4. Right, 46 into 4 whole divided by 3. 61. So its answer is 61.33. This much is the energy radiated per second we got. The 61.33 means nothing but it is a close value to 60 joules. So that yes, option A is also correct. So for this question, option A is right, B is right, C is right, but option D is wrong. Dear, simple question, just as per the given data, you just get a general equation and then compare the options. So you will get the answers. Next question, this is 2018 advance. Right, two conducting cylinders of equal length are equal. Okay, given in the diagram also it is visible, length is same. Okay, temperatures are 300 Kelvin and 100 Kelvin, fine, as shown in the figure. The radius of the bigger cylinder is twice that of the smaller one. Here data we need to write carefully. Radius of the bigger cylinder is twice that of the smaller one, and the thermal conductivities of the materials of the smaller and the larger cylinder are K1 and K2 respectively. And if the temperature at the junction of the two cylinders in the steady state is right, junction temperature also given 200 kelvins. So what we need to find here, K1 by K2 ratio is how much? Shut up. So K1 by K2 ratio, fine. I just redraw the diagram in a simple way here. This is the first rod given, having less area of cross section. And this is the second rod, area of cross section is more as per the question. Okay, so it is having temperature T1 value given at this end, T1 equals to 300 kelvins, and at this end T2 value given, this is 200 kelvins. And what is the junction temperature? This junction temperature mentioned as, so this is 100 kelvins, right? And junction temperature given as 200 Kelvin. Length of the material is same, means whatever the length is from here to here, so this one is also having same length. Length of the material is same. And thermal conductivities we need to get, this is having K1, this is having K2. And area of cross section, what is the hint given is area of cross section of first rod how much, and area of the second rod how much we need to write. Here they mentioned that the radius of the bigger cylinder is twice that of the smaller one. Means if I take area is pi r square for the first, then this becomes pi into, it is double, right? Because the radius of the bigger cylinder is twice that of the radius of the smaller one. So this is 4 pi r square. Here A1 value, A2 value. Now this is a series combination. If you compare with the resistors in series combination, what happens? How much current flows in the first resistor, same current flows in the second resistor also. Similarly here, these two rods are connected end-to-end connection, that means series only. How much heat flows in the first rod, same amount of heat has to enter in the second rod also. So this is series combination. So just write the equation that dq by dt rate of flow of heat in the first rod should be equals to dq by dt in the second rod. The first rod, how much heat flows, the same amount of heat has to enter in the second rod also. So dq by dt means general formula is what? K1 A1 delta T1. Ka delta T by L formula I am applying. K1 A1 delta T1 divided by L1 equals to K2 A2 delta T2 whole divided by L2. Now substitute the values. K1 value we don't know, we need to find. A1 value is how much? Pi r square for the first rod. Temperature difference. What is the temperature difference for the first rod? One end is having 300 Kelvin, other end is having 200 Kelvins. So temperature difference for the first rod is 300 minus 200, that is 100 all divided by length of the rod is L equals to K2. We need to get A2 value. Area of the second rod is 4 pi r square. This is 4 pi r square into delta T for the second rod. Second rod, one end temperature is 200, other end temperature is 100. It means again difference is nothing but 100. All divided by length is same. Both the rods are having same length. Length value cancel here. 4 pi r square. Here also pi r square cancel. 100 and 100 gets cancelled. Therefore, K1 equals to 4K2 means K1 by K2 value is how much? 4. So they're asking in the question ratio of K1 by K2, right? So answer should be 4 for this question, right? Next one, 2019 question it is. Just to read the question once. This is 2019 question. A current carrying wire heats a metal rod. The wire provides a constant power P to the rod. The metal rod is enclosed in an insulated container. It is observed that the temperature T is the metal rod changes with time T as the equation given. Temperature changes with respect to time. Means temperature is a function of time, you can say. Where beta is a constant with appropriate dimensions, while T naught is a constant with dimensions of temperature. Right. The heat capacity of metal is, right, heat capacity they're asking. So this question not related to radiation because there is no exchange of heat, there is no medium. So those terms are not given here, correct? So directly you can take heat exchange, power supplied here. Okay, current carrying wire heats a metal rod. The wire provides a constant power. Everything is in this line. So let us consider dq. dq, what we need to find here? Heat capacity. Which formula relates heat capacity? How a student get the idea? How can a student get the idea that which equation we have to use? Because heat has different equations also. Yet they're asking heat capacity or thermal capacity. Both are same. Heat capacity or thermal capacity also they can say. That means ms, mass into specific heat is how much. So take the equation dq equals to mc delta t. dq equals to mc dt. This is the relation you have to take. Now power radius means here power given. It provides a constant power P to the rod. Power means energy flowing per time. So that means differentiate both the sides. So dq by dt equals to mc dt by dt. So dq by dt means nothing but power, which equals to mc d by dt of, what is a T value? Temperature here, given temperature is a T naught into 1 plus beta T power 1 by 4. Actually, this is the mistake in this question here. When they have given, it is not 2 by 4, it is 1 by 4 actually. Right. Now, just differentiate this equation. So, P equals to mc d by dt of T naught. D by dt of T naught, I am not writing step by step. Hope you can do this by multiply inside only T naught there. T naught is a constant, so differentiation of constant becomes 0. Leave it. D by dt of, this I write directly. So d by dt of T naught beta T power 1 by 4. Okay. So P equals to mc. So T naught is a constant, beta is a constant. So d by dt of T power 1 by 4 is how much? d by dt of, d by dx of x power n formed n into x power n minus 1. So similarly 1 by 4 into t power 1 by 4 minus 1. So minus 3 by 4 comes here. Here. Next, just rearrange these terms. So P equals to m c t naught beta divided by 4 1 by t power 3 by 4, this is correct. So from this t power 3 by 4, how to write 3 power t by 4? So t power 3 by 4 can be written as, cross multiply the terms, m c t naught beta divided by 4. Keep this equation like this. So t power 3 by 4 we got this much, mc t naught beta divided by 4p. Now t power 3 by 4 is how much we don't know. It is unknown term, small t value. Now go to the given question and take the required data. Time is a function of temperature, they have given. Just write the term here. T of t, temperature as a function of time, equals to t naught into 1 plus beta t power 1 by 4. This is the temperature as a function of time given. Now try to rearrange this. T equals to t naught plus t naught beta t power 1 by 4. Bring this left side. So t of t minus t naught whole divided by t naught into beta. Its value becomes t power 1 divided by 4. Achha, t power 1 by 4 value this much means how to write this everything in terms of t power 3 by 4. Just arrange, multiply. So left side and right side means power 3. So 3 by 4 equals to t of e minus t naught whole cube divided by t naught cube beta cube. Well, left side and right side just to cube it. So this is the equation we got for t power 3 by 4. Let us take this is equation number 2. Substitute equation 2 in equation 1. So if you substitute, let us consider this is equation 1. If we substitute, t power 3 by 4 means how much we got here. So this is the value, t of t minus t naught whole cube whole divided by t naught cube beta cube equals to mc t naught beta whole divided by 4p. Right. Now they're asking specific capacity, means heat capacity or thermal capacity. That means mc value is how much. We need to get mc. So find out the equation. So mc equals to 4p minus t naught whole cube whole divided by t power 4. This becomes t naught power 4 into beta power 4. So this is the final required result for the given question. So mc equals to this much. Means which option? 4p t power 4 beta power 4 means option should be D. Right? Remaining options all are different here. Denominator beta power 4 t naught power 4. So beta power 4 t naught power 4. Right, option should be D for this question. Right, this is which year? 2019 question it is. So basically what I felt is this question just it checks the mental stability of a student and your presence of mind also. Because in the exam sometimes if you see a difficult question, generally you got stuck with that. And the rest of the known question also you cannot do properly. This is such type of question. You feel that initially it is a direct question, easy question, but if you forget or if you do not get the idea how to convert that t power 3 by 4 into known terms, gone. Clear? So student presence of mind, this question checks. This question checks the presence of mind of a student, right? Chala. Next question. 2020. To say this question, a container with 1 kg of water in it is kept in sunlight, which causes the water to get warmer than the surroundings. Okay. The average energy per unit time per unit area received due to the sunlight is 700 watt per square meters, and it is absorbed by the water over an effective area of. That's why I told intensity means nothing but always you have to think about the effective area, not the entire area of the body. Right. Your intensity is given, and this is the effective area. If intensity no, effective area no, we can calculate power. So because P equals to A into I. Assuming that heat loss from the water to the surroundings is governed by Newton's law of cooling. Okay. The difference in the temperature of water and the surroundings after a long time will be. Two methods are there for getting that constant. As they said, no, constant here they mentioned. To get this constant by using Newton's law of cooling. This is one method. And you can use directly this equation also, that is dq equals to mc dt. dq equals to mc dt. But this relates with the constant. Let us take this constant is k. Sir, how this constant came? Because dq equals to mc dt only. dq equals to mc dt, but if you apply Newton's law equation, that is dq by dt equals to e sigma a t b power 4, then there is a constant will come. That constant I have taken as k. Because if you take directly k, so you can save the time and directly also you can substitute, the same result you will get. Right. Here again, dq means in terms of power we need to write this. So differentiate both the sides. So dq by dt equals to mck. Mck is a constant, and this is dt divided by t. Change of temperature with respect to time. dq by dt means nothing but power. Power equals to m into c into k. So dt by dt. So P means nothing but, since power equals to area into intensity, AI. So I will substitute here AI equals to mck dt by dt. So we need to find out here nothing but temperature of water and the surrounding after a long time. What is the difference here? So that means dt by dt value we need to get here. So just rearrange. Rate of change of temperature with time is AI divided by mck. Area value, how much is given? 0.05. So 0.05 into I value is 700 whole divided by m value is 4200 and C value specific heat, the 4200. Mass value is how many grams or kilograms? As a mass is only 1 kilogram, right? Mass value is 1, and k value, k is nothing but a constant, its value given 0.001. 0.001. So rate of change of temperature with time equals to 0.05 into 700 is how much? 0 gets cancelled, so 35 whole divided by, here how much this becomes? 4200 and 1 by 1000, so 4.2. So this becomes, let me calculate, 35 divided by 4.2, right? This is 8.33. 8.33. This much should be the answer for this question. Clear? So simple question it is. Better you take the constant also involving by here only. Otherwise you have to take dq equals to mc dt. This is equation number 1. Second equation is dq by dt equals to e sigma a t b power 4 minus ts power 4, equation number 2. Then again dq values you have to equate and then differentiate. Same you will get. So I have written here the first equation directly. Here. Next one. 2021 question it is. A small object is placed at the center of a large evacuated hollow spherical container. Assume that the container is maintained at 0 Kelvin, means container temperature is not changing, right? It is a constant, it seems. So maintained at 0 Kelvin, they said. Okay. At time t equals to 0, the temperature of the object is 200 Kelvin. Okay, initial temperature at time t0 means initial temperature is 200 kelvins. The temperature of the object becomes 100 Kelvin at t equals to small t. Okay, and 50 Kelvin at t equals to T2. Okay. Assume the body and the container to be ideal black bodies. The heat capacity of the object does not depend on temperature. The ratio T2 by T1 is. Simple question it is. Simple means, of course, we need to get the idea. There is no exchange. You can consider emission process here, because here container temperature how much? 0 Kelvin. Hot body is there inside. Hot body is emitting radiations. So if the hot body emits the radiation, listen my words, then you will automatically recollect all the formulas. Emission of radiation per second. Emission of radiation per second. That means dq by dt, not net rate flow, only emission. So dq by dt equals to E sigma A T B power 4. This is the equation we need to apply. So dq by dt equals to E sigma A T B power 4. Yeah. Now, temperature changes here. Small object is placed at the center of a large evacuated hollow spherical container. Right. Assume that container is at maintained 0 kelvins. Okay. At time t equals to 0, the temperature of the object is 200 kelvins. Right. Now the temperature of the object becomes 200, and this may assume the object and the container to be ideal black bodies. Black bodies means small e value can take as 1. The heat capacity of the object does not depend on temperature. Okay, heat capacity. Right, heat capacity means dq we have to relate with heat capacity. How to relate dq with heat capacity? Is dq equals to mc dt. Substitute here. dq means mc dt whole divided by dt equals to E sigma A T B power 4. Now rearrange the terms here. Temperature terms I will write one side, and the time terms I will write other side. So here dt divided by t power 4. So tp power 4 equals to E sigma A divided by mc into dt. If you observe carefully, this everything is constant. This total term is a constant. Small e constant, sigma constant, area of the given spherical object constant, mass constant, c also constant. Here. So integrate it, because temperature is changing, so that we can apply integration. Before integration, I take like this: dt divided by t equals to this total term I am writing as k dt. Now apply integration both the sides. Temperature is changing from where to where? So temperature is t power 4, this is right. Temperature is changing from where to where? Initial time 0. Now the time is t1 second. Initial temperature is 200 kelvins. Say the question once. Initial temperature is 200 and its temperature becomes 100 kelvins. Right. This is 100 kelvins. Now, so if you apply integration here, so we'll get the relation like this is equation 1 also you can consider. Correct, because here I am taking 0 to t1 time. In 0 to t1 time, and temperature changes from 200 to 100. So dt by t power 4 equals to k into dt. Sir, why you have written k? What is a k? By k is a constant. Because E is constant, sigma constant, A constant, N constant, C also constant. This everything Everything is a constant. That's why I have replaced, instead of this whole term, I have replaced it K. Let us take this is equation number 1. Now second equation. From 0 to T1 degrees, 0 to T1 seconds, temperature is changing from 200 to 100 kelvins. Now, what is the next process takes place? From 0 to T2 seconds, how much is the change in temperature given? I write the data. From 0 to T1 seconds, temperature is changing from time 0 to T1 second. Temperature is changing from 200 to 100 kelvins. This is first process, what we have written now. Now, what is the next process? Next process time is time. If I write from 0 to T2 seconds, temperature is changing from 200 Kelvin to 50 kelvins. This is the step 2. So this is the second process. What is the second process? I just write here. So integration of so dt. These terms will not be changed. Only integration limits will be changed. Rest everything is same integration. Dt by t power 4 equals to k into integration of dt. So limits I take from here 0 to T2, and here initial temperature 200 to 50 kelvins. So let us take this is equation number 2. You just divide equation 1 and equation 2 so that you will get the final result here. What is the required thing? Required thing, they are asking that assume the body, the heat capacity does not depend. The ratio of T2 by T1 is how much? So just divide. Apply integration and divide. Apply the integration, not direct division. Apply integration and divide equation 1 and 2. So divide equation 1 and 2. So if you divide equation 1 and 2, then required result. So T2 by T1 is how much? So T2 by T1 they're asking. So we will get the answer for this. Yeah. Just do it as a homework I am giving. Just apply the integration and divide both the equation. You will get the final result. Here. Next one. This is 2024 question. The specific heat capacity of a substance is temperature dependent and is given by. Very easy question it is. I don't know why they asked this question in advance. So simple. See, of course, not all questions are very tough. If they frame tough questions, it takes more time also. If you take 19 questions, generally 19 advanced questions are there in paper 1 and after paper 2 also. Some questions are tough. Some questions are medium level, some are easy level. This question belongs to easy category question. Right. The specific heat capacity of a substance is a temperature dependent. Understand the things. From the questions also you can learn so many things. Specific heat of a substance is temperature dependent. In this particular question, specific heat capacity is a temperature dependent. And if you observe in the previous question, this question you observe, what is MC here? MC is nothing but a specific heat capacity only. But in this particular question, specific heat capacity is a constant. That is why I have taken the whole term as a constant. And in the question also they mentioned the last line. The heat capacity of the object does not depend on temperature. Got it? So that's why heat capacity, sometimes it may change with the temperature, it may not change with temperature. There is no guarantee that specific heat capacity is always remains constant. No, it may change with respect to temperature. But basically mains level, whatever the questions we are discussing, almost we consider that the heat capacity remains constant. Whenever heat capacity is changing, you need to integrate it. Simple thing. Next. 24 question, this one. So heat capacity is a temperature dependent and is given by the formula C equals to KT, where K is a constant of suitable dimension is SI unit and T is the absolute temperature, right? Absolute temperature means Kelvin units we are using. the heat required to raise the temperature of 1 kg from the substance, 1 kg of the substance from minus 73 degrees centigrade to 27 is Nk. The value of N is also nothing but C value, specific heat capacity or heat capacity is changing this time. Take a let it be. So we'll take here dq. dq equals to mc dt. This is the equation we have to take. So dq equals to m into C value is a variable, so that's why substitute here. C value how much? Kt. So Kt dt. Now integrate both the sides here. So if you integrate left side and right side, we have to apply integration. Integration dq is nothing but q, which equals to m is a constant, k is a constant. Integration of t dt is nothing but t square by 2. So limits from where to where? Limits we have to take from minus 73 degrees centigrade to 27 degrees centigrade. But you should not take degrees centigrade. You have to convert into kelvins. Absolute temperature we need to take. So 273, 27. So this is 300, right? So 7310, 7310, 3. So 300. This is the upper limit. And where it has started minus 73 initial temperature. So 273 minus 73 nothing but 200. Because this is negative. In the question only they mentioned, you see the last line. Minus 73 degrees centigrade to 27 degrees centigrade, we need to raise the temperature. To raise the temperature, how much amount of heat we need to supply? And here the condition is specific heat capacity is not constant, it is changing for the given substance. That's why you have taken integration method and we are applying. Clear? So 300 and initial it is 200. So, okay. Now Q equals to m into k all divided by 2. First of all, upper limit substitute here 3 t square means 300 square means this is 300 into 300, 90,000 minus upper limit is over, no, lower limit 90,000. Correct. Next lower limit is 200 all square, this is 40,000. So Q equals to m and k values. What is it? M and k, m value, k value. The substance is changed from Nk, the value of N is acha. What mass of the substance is given? 1 kg, right? Mass of the substance given here 1 kilogram. Right? Substitute that value. Mass value is 1. This is k all divided by 2. 90,000 minus 40. So this is 50,000. So cancel the terms. So Q equals to 25,000 K. In the question they are asking Q equals to N into K. What is N value? So if you compare, N value is nothing but 25,000. Right? That's okay. Therefore, N equals to 25,000. So this is the answer for the given question. Easy question, simple question. Just we need to apply integration because specific heat capacity is changing. Next to last, this is 25 question, 2025. This year question only. Just to see the question once. Two identical plates P and Q radiating as perfect black bodies are kept in vacuum at constant absolute temperatures Tp and Tq respectively, with Tq is less compared to Tp. Means heat is flowing from P to Q, right? Because P is more temperature, Q is less temperature, so heat flows from hot body to cold body as shown in figure. The radiated power transferred per unit area from P to Q is W0. Okay, this much is the power radiated from P to Q in the first case. Now there are two metal plates. Okay, two more plates identical to P and Q are introduced between PQ as shown in figure 2. Assume that heat transfer takes place only between adjacent plates. Means one plate. If you take 4 plates here side by side, first plate to second, second to third, third to fourth. So adjacent plates cause heat flows. Right. In steady state is Ws. Whatever the heat flows here means power, that is Ws in the second case. What is the ratio of W naught divided by Ws they are asking. Simple only this one also. Let us analyze the figure 1. Right, first figure I am analyzing here. So metal plate, there are two metal plates. Let us take, this is P, first metal plate, and here this is the second metal, right? Second metal plate. Here I will take, this is Q. P and Q, two metal plates are there. Right. P, Q. So heat flows from P to Q in this direction, and W naught is the heat. So Tp is the temperature of P material, Tq is temperature of Q material. Now radiation process they said, right? So in the question it is mentioned that radiating perfect black body. Okay. When they behaves as a perfect black body, so write the equation here. So dq or P equals to E A sigma Tp power 4 minus Tq power 4. Hope you understand. High temperature to low temperature heat is radiating. So we have to take P equals to E sigma A Tp power 4 minus Tq power 4. This is equation number 1. But P value given how much here? Don't take it as equation number. Let me change it. But here how much is the rate of flow of heat? That is W naught. So W naught equals to E A sigma T P power 4 minus T Q power 4. Now take this one as equation 1. Fine. In configuration 2, second figure. Now we'll analyze about figure 2. So take here 4 identical conductors. First one. One, two, three, and then last one is 4. Okay, 4 identical. All are identical here. So let us take it is P. P and Q are same. But between P and Q, what we have done? We have introduced 2 more metal plates which are similar, identical to that of P and Q. Now this is temperature of P, this is temperature of Q. What is the temperature of the metals which are introduced between P and Q? Don't know. Take these temperatures are T1 and T2. Obviously they also should have certain temperatures, right? Then only heat is flowing. Heat flowing from P to first plate and then second plate, then finally heat reaches to the plate Q. So temperature is given here. How much is the rate of flow of heat? Let us take, they mentioned Ws. That means here also how much flows? Ws. Here also Ws. Okay. Now write the equation step by step. First of all, between Tp and T1, right here, for plates for Tp and T1, equation I am writing. So Ws equals to just apply the formula E sigma A Tp power 4 minus T1 power 4. So E sigma A Tp power 4 minus T1 power 4. This is one equation. Here, next one. For T1 and T2, I am taking two plates and I am applying the equation. Here. So for T1 and T2 plates. That is the equation we can write. Same. How much heat is flowing? Rate of flow of heat is how much? Same. Ws equals to E sigma A T1 power 4 minus T2 power 4. Okay. Next one is between for T2 and TQ. For T2 and TQ plates. So here we can write Ws equals to E sigma A T2 power 4 minus TQ power 4. Here. So these are the first three equations we got for the given metals. Now add all the above equations. So add, let us take this as equation number 2 because this we have taken as equation 1. So I'm taking this as equation 2, equation 3, equation 4. So add equations 2, 3 and 4. So if you add here, left side value is same, LHS is same because same amount of heat flows per second. So if I add 3Ws equals to E sigma A, I can take common and what left here? So Tp power 4 minus T1 power 4, Tp power 4 minus T1 power 4 plus second equation is T1 power 4 minus T2 power 4 and third equation is T2 power 4 minus Tq power 4. Right? Now cancel the terms, what and all gets cancelled. Minus T1 power 4 plus T1 power 4 minus T2 power 4 plus T2 power 4 cancel. So remaining is 3Ws equals to E sigma A Tp power 4 minus T1 power, sorry, Tq power 4. Tq power 4. But we know already 3Ws equals to what is E sigma A Tp power 4 minus Tq power 4. Just substitute the value. Here equation 1 we got, that is W naught. W naught. Clear? In the question they're asking ratio of W naught by Ws. So therefore W naught divided by Ws equals to 3. This is the required relation here. Here. So this is the end of advanced questions of thermal properties of matter. Now maybe next Sunday I will post thermodynamics also. Once thermodynamics is also over, then I try to post oscillations also. Every week by week I'll try. And first you just get clarity on mains level questions. Okay, at least last 5 years or last 3-year question paper. Take PYQs and solve PYQs of last years. And advanced questions, you just practice advanced questions also. Maybe first time you may feel difficult for solving advanced level questions, but it is not that tough. Once you are habituated for solving, then you can solve any advanced questions. And never give up. Okay, seeing advanced questions only, don't afraid. Many times, number of times I'm telling again, you are afraid of solving tough questions. First start with easy questions only, practice, make comfortable yourself with the concepts, then try for advanced questions also. Yeah, initially everything is tough only. Beginning is always difficult for anything. Once you habituate, it becomes so simple. Okay. That's it. So I'll end the meeting. Okay. So take care. Bye bye.